So we're mic'd up. Okay, so today we're going to go over migrating your jobs from Jenkins Job Builder to Ansible Playbooks, which is kind of the story of Zuulv3. Hopefully interactive, so if you have questions, just put up your hand. We'll cover them right then and there. I don't really have a lot of slides. We can go into as much depth as we need to, or just power on through and go for beers kind of thing. So let's get started. All right. So who am I? So my name is Paul Belanger. I work for the...
Can you put a bigger font?
Oh, how did I know somebody was going to ask that? No, I can't. I have to change the refresh rate, unfortunately.
No, just the font size maybe.
Yeah, let's try font size. Why not? Font size. Control what? Let's try zoom in. No. Oh. Let's do it again. Huh? Is that better? A little bit? Okay. Sorry. So this is my first time using this presenting software. It's called Present TTY. It's written by Jim Blair, who's the same person who's the architect of Zuulv3. So you might. Anyways. So I work for the OpenStack project infrastructure team. For people who do not know, we are the team in OpenStack that manage and run all the services for the OpenStack project, such as code review, our Git farm, mailing lists. We have a PBX that we run. All these systems fall under our umbrella, and everything is orchestrated via a code review system. We primarily use Ansible to kick off Puppet to manage these remote nodes and so on and so forth. So hopefully you'll kind of see where Zuul and Zuulv3 kind of fits into some of that aspect of it. So what are we going to talk about? So right now we're going to talk about Jenkins Job Builder. Does anybody not know what that is? Hopefully everybody in this room has at least used it or is using it. So JJB, as we refer to it, is a tooling that we've written in OpenStack Infra to help us manage our Jenkins jobs in a more code review friendly fashion, which was basically writing all these job definitions in YAML or JSON and allowing us to review them in human readable text. And the reason why we wanted to do this is we didn't want to have to, manually go out to all of our 8 Jenkins masters that we were running and point and click and copy pasta from one to another. We wanted to store this in source control versioning so that we had a history of it, because unfortunately at the time, and to be honest, I don't know if there is any support of history of jobs. So if somebody either maliciously deleted a job or accidentally deleted a job, it was very difficult using the web UI to go back and put it all in. And like I said, it was to make easy for humans to do code review, and basically allowed for a flexible templating system. So we could create very generic templates in JJB to express a builder for building a shell, or in the example that I'm going to show, a hello world. But it allowed for more other things such as log publishing, log collection, remote notifications, and so on and so forth. So that was how the OpenStack project used to manage it all. And I think we were up to 15,000 total jobs across the project. So our JJB folder was quite large and I want to say a little bit complex, and but it was a great way that we could point developers to that, and they could go in and try to make job changes and so on and so forth. So the next thing we're going to talk about is Ansible. Anybody not know what Ansible is? Hopefully everybody here has used Ansible or wants to use Ansible or so on and so forth. But basically it's a simple and powerful IT automation tooling. Simple is basically you just need an SSH connection to a remote node. And 9 times out of 10, if you are managing a remote node in the context of a Linux node, you have SSH. You're not either using a DAC card or so on and so forth. Again, it is written in YAML and or JSON, which allows us to do human readable text, storing source control, which makes it very easy to make changes and code review and flexible templating system. So hopefully you're kind of seeing where I'm going with this is this slide, I just changed one line or two lines and copy and pasted it to kind of show that the two, in the context of job creation and job testing, they're very similar in that aspect. You can express how you want to do a test in a YAML format, which allows for us to do something with a remote node. In the first case with JJB, we're depending on an external tool such as Jenkins. So we wrote a tool to pipe that from YAML into XML into Jenkins, whereas with Ansible, well, there's no external thing. Ansible is the remote execution of the code that you're writing, so it's one layer taken away. So what we're going to talk about now is there's no Jenkins, there's only Zuul. Actually, I didn't even ask. Does anybody not know what Jenkins is? Because I probably should ask that the first question. So what we wanted to do is, up until last week or the week before, we were running a version of Zuul that, from our point of view, still had Jenkins integration. We refer to it as Zuul 2.5. However, we actually replaced Jenkins with Ansible. And the reason we did that, not to get into too many details, but there was a remote execution exploit that allowed any public Jenkins server to be hacked very easily. And we, as the OpenStack Infrastructure team, caught wind of this exploit, and literally our defense was just turn off the firewall for the jobs, the running jobs, and give no web access. So all of our testing was still running, but it didn't give results for developers to look at and so on and so forth. And basically in about a week's time or 2 weeks' time, Jim Blair wrote Zuul 2.5, which converted Jenkins Job Builder template files into Ansible Playbooks. And it was super hacky, and it was super fantastic because it made debugging very difficult. But it worked. It proved that the notion of using Ansible as the remote execution engine was like a sound principle. So that was one of the stepping stones to get us to the Zuulv3 spec, which basically is right here some of the reasons what we wanted to do, which was basically make Zuul scale to thousands of projects. So today in Zuul 2.5, we actually already had that because we have 1,500, 1,200 projects in the OpenStack project. And when I refer to a project, I mean like a Git repo that stores the project. We want to make it more multi-tenant friendly. So just like a cloud, you want to have tenants in your Zuul configuration where you can say, company A can have this part of Zuul, company B, or maybe subteam C, subteam D, instead of a master global namespace. We wanted to allow to express more complex scenarios, which kind of ties into more of multi-node testing. We really wanted to make multi-node testing a first-class citizen in Zuul. For people who have not used Zuul, you could do multi-testing before, but it was a very not a complicated, but it was a clunky mechanism. You would basically say, give me 2 Xenial nodes, and these would be your multi-node scenarios. In Zuulv3, you can say, give me 2 nodes and make one of them CentOS and the other one Fedora. Or give me 15 nodes and make 5 of them Fedora, 2 of them OpenSUSE, 1 Tumbleweed. Like, it's really meant to, blow out multi-node testing and so on. We wanted to make node pool. I haven't talked much about node pool, but node pool is the mechanism that gives us the nodes. We basically say to node pool, hey, I need 15 nodes, and node pool will go out across multi-cloud regions and satisfies those requests by booting images and setting up SSH keys to ensure that we have credentials to log in and so on and so forth. Again, make it more efficient in multi-node testing, which I've basically explained. Remove the need for long-running slaves. So again, slaves is a Jenkins term. We had this idea of we would stand up long-running slaves on our control plane specifically for the purpose of storing credentials. So keys for PyPy publishing, uploading of tarballs to publication sites, Docker Hub, for example. That was a very complex process. If a project wanted to publish to Docker, they would need to get basically the sign-off from the infrastructure team to host this service on our control plane, which, I mean, it's not difficult to stand it up, but it's a lot of, I don't want to say, what's the word? I don't want to say politics or something like that, but it required planning and scheduling, and you needed certain people with root credentials and times and so on and so forth. And then basically we just wanted to make it easy to do continuing deployments of Zuul, private installations. So most of people that run Zuul today kind of do it in a public environment in the sense that they might run it on the public web, or they might have a public cloud that they run against. Zuulv3, we allow for this concept of internal, you're behind a firewall and Zuul can get to you, or vice versa, you're not behind the same firewall as Zuul. We've built it into that. And basically just keep Zuul simple. And what I mean by simple, we didn't want to write remote execution into Zuul. We knew of a better tool, and that tool was Ansible. So we wrote Zuulv3 to leverage Ansible Playbooks and roles for actually doing the job definitions. We didn't want to go out and write a new sort of format to express all your jobs in. Since Ansible is primarily the dominant thing now these days for deploying production things, production clouds, production software, rolling updates. It's a great automation tool. We figured, hey, Zuul, it would work well with Zuul to integrate with that. So this is what it looks like, which is pretty funny because it's an ASCII conversion of the graph they wanted to use, but I couldn't figure out how to actually do the right graph. So let's go to this page. So this is what it should look like. And at the heart of it, whoa, it's freaking out a little bit. So we have these concepts of Zuul. Zuul is, oh no. Everything good? Okay, I'll make it quick. So the merger, we have a concept of a merger, which is doing git merging of operations for future speculative states. Oh yeah, this thing's not doing good. It's going to blow up here. An executor, a web. All right, I'm going to flip back. But basically, superimpose this graphic to this awesome ASCII diagram, okay? Top parts are our mergers and so on, web interfaces of Zuul. It's pretty awesome. We have Gearman, we have Zookeeper in there, we had Node Pool. If I can figure out how to get the refresh rate better, we'll go back to that one. So the idea is, what I'm going to show you is a couple ways of how we used to do JJB. And this is how you, as a developer, would actually try to test your JJB templates for your testing capabilities. Very often, an OpenStack developer should have been doing this. Sometimes they didn't because we had project gating all in place. But you create a virtual environment called JJB env. You activate that virtual environment, and you pip install Jenkins Job Builder. Okay? That's the very basic thing that you needed to do to configure Jenkins Job Builder on your node or on your remote system. Then you would write a very simple hello world. And this, again, is JJB syntax, where we create a name, a description. Jenkins has a concept of builders, which is where you define what that task is going to do. So in this example, we're going to basically echo hello world. That's our test. Now, this is just for very simple 5-line demo, but some of the JJB examples that we had were quite complex. I want to say 100 lines, 200 lines. We're actually embedding Python code or Bash code right into this definition. And the next slide you'll see is this is how you would actually test it. But if you actually look, we're not actually testing that hello world worked. We're testing that JJB was actually able to output XML that we would then inject into Jenkins to then test it, which often led to broken code being landed in our testing because there's no sane way to actually test this, aside from copying and pasting into shells locally or blindly pushing it up and hoping that it worked. And if you worked in the OpenStack Infrastructure project, you kind of got really good at parsing this in your head, but not even us could figure out, is it, should I use 2 square brackets or 1 square bracket of this bash code or more complex scenarios? And to be quite honest, what it led to is if you're trying to test production deployments of your code, you're not driving it usually from Jenkins. You're driving it from another tool, maybe like a Puppet or a Salt or a Chef or something like that. So what end up happening is you start creating technical debt of carrying the code to test it, and then some other method of actually putting it out to your production cloud or your staging environment and so on and so forth. We didn't want to do that. And basically, like I said, it required a lot of iteration for developers to kind of get their test just right, a lot of wasted time, and so on and so forth. So basically, to recap, the idea with JJB was, for a long time, this is how we in the OpenStack project had to deal with things. And the pros were no longer editing jobs in the GUI. It scales. We could put this over 8 Jenkins masters. Version control, code reviews. We could validate that the job syntax itself was correct. The cons were, well, it was very difficult to actually test the job without throwing it to a Jenkins server and running it. And as a developer, you probably don't have the resources locally to set up a Jenkins master or the time to set it up and validate that everything works and so on and so forth. Again, like I said, additional testing code to maintain. So somebody on your team had to maintain it for the purpose of just testing, aside from production deployments. And like I said, it converted YAML to XML, which was just basically another layer that you needed to deal with for debugging things. So that's the bad. That's the old and busted, okay? Now we're going to talk about the new and hotness. So again, we're going to create a new virtual environment. We're going to source it. We're going to install Ansible. Okay, so far we're on the same level of difficulty of installing the piece of software. Okay, 3 lines, it's installed. So now we're going to create a hello world. So again, it's in YAML. We're going to create hosts. We're going to run it on all the hosts because, to be honest, we want this job to be generic enough to run on any host. We can say we only want to run this on Ubuntu hosts because the Echo version that we're going to use has something Ubuntu specific for a feature flag, but we didn't do that, right? And we're just basically going to create a task that says, hello world, and we're going to print it out. So to everybody, this should be, if you've used Ansible, this looks like a normal Ansible playbook, right? So how do we check the syntax of this code? So Ansible has a really cool syntax checker, which we can run Ansible Playbook. We pass an inventory. I just noticed a bug in my presentation. I didn't show you what the inventory was, but I can, as long as the monitor doesn't freak out again, I can show you what that inventory is. But basically, we leverage the the Ansible connection called local, which means it will basically use kind of a loop back shell on your node and not use SSH. You could use SSH, but it would require setting up SSH keys, starting the SSH daemon, and so on and so forth. For the purpose of this demo or for the purpose of testing, I don't really need to validate that SSH works. I can leave that to Ansible and assume that Ansible is good enough to ensure that SSH works. So yeah, so we're going to run this command, and it's going to validate that our syntax is correct. And that's actually what it does. It just spits back playbook, hello world, run, YAML. It's good. So that kind of is equivalent to the first JGB thing where we could ensure that the syntax was correct, right? Okay, so the next thing we're going to do is we're going to actually lint our playbook. So is anybody not familiar with linting? So just to recap, linting is making sure that you have 4 spaces, you have parentheses around the code block, the syntax is valid. Maybe it has some specific recommendations of in Ansible, like if you don't need to use bash variables, you should use the command. Did I use the command or did I use shell? You should use the command, right? Because I don't really need a shell. If I was doing something with variables, then I would pass the shell task. So things like this. It kind of helps enforce rules and regulations to your playbook, which make them easier, ideally, to do code review. What ended up happening is 9 times out of 10, you write your playbook and you forget to test it locally and you push it up to your testing and then it screams at you that you didn't put 4 spaces, or you put a hard tab instead of 4 spaces and then you rage at your laptop and throw it and things like this. So it's a very simple way to ensure that the Ansible code is actually valid without actually running Ansible. And finally, there's actually a way to run Ansible locally, which again, we just say run this playbook using this inventory file. And we're going to use the localhost connection, which you can see I've set up localhost on the presentation. And it runs. It gathers facts about my machine for purposes of referencing variables later on. Excuse me. It actually prints hello world. Because I don't have verbose on here, we don't actually see it happening, but it prints it on the local host. And then it recaps what's actually run. So, recap. So it's more powerful in the hands of developers. It's an IT automation tooling. Again, it scales, allows us to do version control, syntax checks, no external service needed, so we don't actually need to have a Jenkins system on next to our desk. We can run it all on our laptop locally. Should be like an asterisk beside that, because if you actually apt-get install libssl version 15, it's actually going to install that on your laptop. So you might not want to do that, right? There's a way to do, is it dry run, I think it's called, right? Ansible has a dry run mode where you want to see all the tasks happen and not actually do things. I didn't put it in this demo, but that would be a way to kind of protect against that. You can implement tagging or skip tags, I think it's what it's called. And more specifically, it allows you to actually use your production playbooks. So again, just to recap, if this was a production playbook that said pip install Nova, run database migration, that's that task. That's how you would run it in testing and in production. It's the same playbook. So you don't have to maintain separate things for testing things. You're running the same production code in a testing environment. And the only thing that's changing is the inventory file where you're defining where that code runs. That's really the benefit that we're trying to instill in Zuulv3, right? Run it like, I think Monty Taylor did a talk with test it like you run in production. That was his talk. And what really hit home was you don't run your production code from a Jenkins or from some CI testing tool. You usually have a second set of QA or QE people that manage that, and then you pass it over to your ops people that have their own playbooks to actually deploy all the code. This really does the dev and the ops, puts it together, and then a single piece of playbook could actually do this in testing. And because the way that Zuul is written, you can have multiple pipelines to change maybe in a different pipeline. So imagine you have 2 pipelines. One is the testing pipeline to ensure that it actually validates and works. Once the code is landed, then you have a post pipeline which might continuously deliver that playbook to a production server and actually reload live code and so on and so forth. So from cradle to grave, Zuul kind of gets that pipeline through your CI, right? So let's talk about Zuulv3 and Zuulv3 configuration. So anybody use Travis CI? People know of Travis CI? What's the big thing about Travis CI? How do you configure Travis CI? You put your configuration in the project, and it reads that configuration and runs the tests. The way that Zuulv2 ran, that was an external configuration via Jenkins, and we had to reload, land code, reload it, wait 15 minutes to get deployed across 8 masters, or eight Jenkins masters, and so on and so forth. With Zuulv3, this isn't new ideas. We're using the concept that Travis CI does, but we take it to the next level, I think. Zuul has this concept of speculative changes. So one of the cool things is, and hopefully I got enough time to show this, is I've proposed this patch, which actually runs the Hello World playbook. So that's the job definition at the top. So again, we're saying the name, description, we want to run this playbook, which is the playbook Hello World run, and we're assigning it a node set. And the node set really maps to the inventory file of an Ansible playbook, where we're saying these are the type of nodes that we want on the remote end to actually run this code on. And in this example, we're saying the node is going to be called controller, and it's going to use a label of Ubuntu Xenial. So that we're telling Zuul, give us an Ubuntu Xenial node that's called controller. Again, in this example, we're just saying hello world, but imagine you're deploying Keystone on that controller, or some database on that controller that might not have to run on a compute node, because on the compute node, you just need Nova Compute. Or maybe you have Cinder volumes on another. Like I said, you can express the nodes in your configuration. Before in Zuulv2, it was very difficult to do this. And then we have a project pipeline. Again, for the purpose of this talk, we're saying check is we run it. When we upload the patch to code review, it runs this series of tests. And then when somebody approves it, that's the gate, it will run the same test. So we're saying run 2 tests on upload, and then when somebody approves this code to LAN, run the same tests again to ensure that it's actually working. And basically, this is the representation of that hello world running on a remote node. Now, hopefully the monitor doesn't bomb again here, but so hello world. So there's much, much more. Is there any way I can have it stop doing that, or is it my refresh rate, or?
It might be the program in your presentation open in the other.
Okay. So again, there's a lot of, what I'm trying to convey here is we have this concept in Zuul of onioning playbooks. So we run, Zuulv3 will run jobs in an inheritance structure. So we have a concept of a base job. And in a base job, we say, we want these Git repos on the remote node. Or we want to set up mirrors for packaging and so on and so forth. These are what I refer to as like infrastructure level playbooks that the infrastructure team want to ensure give the job the best chance of passing. You as a developer, you care about that, but you don't need to run that in production because you might have another playbook that does that. In the context of this example, we were saying we just want to run Hello World on a remote node. I don't care really what happens before it. I don't really care what happens after it, because in the context of this patch set, this is all I wanted to test. And like I said, after this, we have a concept of post runs where you maybe write an additional Ansible playbook, which is used for log collection, stats notification, and so on and so forth. So achievement unlocked. We basically took a Hello World playbook. We ran it both on localhost, and we run it on a remote node. We didn't make any changes to our job, and we just basically told Zuul what we wanted. And as basic as that sounds, it's super powerful. It allows you to no longer have to take 2 sides of the same coin of how to run that code in production or in testing. And you can now focus on a single deployment method and just tell Zuul via Ansible where those nodes live, and the code runs on that remote node. And like I said, because this concept of in-tree definitions, and in the context, I'm leaving a lot of stuff out here because Zuulv3 itself is probably a 10-hour talk, but Zuulv3 has this concept of dynamic reconfiguration of itself, of a project. So what we can do is, in this node set, we can actually propose, okay, give us a compute node that runs on Fedora, submit the job again, and now 2 nodes will appear via node pool, and we'll run the same task on both nodes because we're saying run on all hosts, this syntax. But if in your Ansible playbook, like I said, you said this code path runs on a controller, this code path runs on a compute node, Zuul doesn't really care about that because that's Ansible's job. We just give you the node, and Ansible takes over, and that's how awesome or why Ansible is awesome. It's very simple to run remote code and so on and so forth. So, any questions so far? Yes?
What declares like the success of the jobs? Just the Ansible response?
Yes. So the question is what declares a job success? We basically use the return result of an Ansible playbook task. So that could be basically 1 is failure, 0 is non-failure. However, Ansible returns other codes, such as, I think it's exit code 2 is unable to connect to remote node for some arbitrary reason. Zuul kind of takes that into consideration for the non-0 and 1, and will reschedule the node, or reschedule the job to run again up to X amount of times. As an example, maybe you're on a very poor network, right? You don't want the job to fail because you have a poor network. You just want to reschedule it and have it try again, kind of thing, right? So Zuul itself doesn't really define what is a failure or a success. It's all in Ansible, and we just pass that straight back to the job. Yes?
So the Ansible itself can maintain the dynamic inventory for the nodes, right? Why do you want, what's the scope for Zuul?
So the question is, Ansible has its own dynamic inventory capability, right? That usually happens after you've created your cloud, or actually after you've provisioned your nodes to scan that inventory, right? We don't, at the job, because of how node pool works, we don't want to keep 1,000 nodes online all the time. So we just keep online, say 10. So we don't know what that node is at the far end. So Zuul asks node pool to give me that node, a dynamic node. When it returns back the port and the IP address of that node, we then populate it just straight into an inventory file for reading. Now, why we didn't use dynamic inventory for that is ultimately we want people to be able to download these playbook runs after the fact and have the ability to rerun them. So by providing the inventory file directly, it allows a better use case for that scenario, right? In a case of a dynamic inventory, you need an endpoint somewhere to scrape that data, right?
So Zuul maintains the dynamic inventory and stuff.
So the question is, Zuul maintains a dynamic inventory? Not really. Zuul asks node pool for the node, and node pool is the one that's managing all those cloud capacity and quotas and so on, and returns back that node. Zuul says, thank you, run playbook against this node, and when done, Zuul tells node pool, we're done, and node pool deletes that node and gets rid of it. So we got a couple minutes left, so I'll kind of go through this part a little bit quicker. So now let's run the syntax, the lint checking job. Let's write a Zuulv3 job to run lint checking. So then we can gate linting. Instead of running it on my local laptop, we can run it on a Zuul. So same thing, we create another review, and basically we have this concept, like I said, of a pre and a run. So in the pre, maybe we want to just ensure that Ansible lint is installed because that's, in my mind, a separate process than the actual linting of a job, right? And I just wanted to show how we have the concept of pre-runs, runs, and post-runs, right? So we have two playbooks. First one installs Ansible lint into the user namespace. Excuse me. And then we run Ansible lint on our playbooks directory. The piece that's of interest is this Zuul variable, so zuul.projects.source directory. This is the variable that we populate in the inventory file. Again, didn't add an example of it, but we populate some information such as the type of project that was cloned, maybe a reference in Git, could be a stable branch, could be mastered, could be a specific reference of code review. All this is saying is on the remote node, it's in this, run this task in this job directory. Otherwise, I would have to write out the full path for the Ansible lint. And the same thing, let's run it on Zuul, so we submit it. Again, all the pre-run inventory for mirrors get set up. The blob of data that's important to us is installed Ansible lint on the controller. Changed means it was good. You can see a pre-run start, a pre-run end results is normal. And then we run another task of Ansible Playbook, which says, okay, now lint our playbooks. And because the return code was 0, which meant it was okay, came back and said it was good. And again, run start, run end, results is normal. These are this is just the view from Zuul of the results. Same thing, let's create a playbook for syntax checking. Same thing, we create a pre-play, which allows us to install Ansible in pip. Now, I could have condensed this pre-playbook into a pre-run task for this playbook that installed both Ansible and Ansible lint. And then I have a single pre-playbook, but have two different run playbooks. So again, you can kind of see some of the inheritance and mixing and matching. And same thing, we run syntax checking, source directories, and it comes back and basically says it was good. So I think I only got a couple minutes left here, about 3 minutes or something. So these are some of the jobs that we've created in Zuul, which allow you to, and this is just an example, build a JavaScript tarball. We've created a playbook to do this. For Python sdis, which we use for publishing Python. Tox is our entry point for running jobs. We, as the infrastructure team, take responsibility of writing these jobs so that you can just simply reference them on a later playbook run. So Zuul has this concept of parenting. So you would parent to our Tox playbook and then pass specific arguments into Tox to do different things. Yes?
I've run into one case where it would have been appealing to have multiple inheritance.
Right.
Is there something planned, or?
So the question is multiple inheritance.
Yeah.
So right now, I don't believe there's a plan to have multiple inheritances. You can serially do multiple, like you can have a parent to a parent of a parent. But the way, if I'm understanding correctly, you want to have a parent and then inherit from two parents, right? To then run a job. No, unfortunately, we can't do that today. It's probably something to bring up to the infrastructure team of why that's a problem for you. There's right. Yep. So a lot of this we're learning about how all of this works. So there could be a valid use case to do that. And I would encourage you to follow one of these links for more feedback or for more information. Like I said, it's in production now, but we're on week 3, and it's still a little bit of a moving train. Not a lot, but we haven't officially tagged Zuulv3 yet. So there's potential for some syntax changes and so on. But at the end of the day, some of the examples that I've shown here are actually valid and running in production. And if my monitor doesn't freak out one of the coolest parts of this is actually live streaming of Ansible. So you can actually see this. This is a terrible one because it's the job failed and is going to clean up. I can already tell. Let's go down and find one here. Let's do this triple-O job. Might be a bad one because it's might be sitting pending something, but. So this is all HTML5 WebSockets right to Ansible. So we've written this live streaming plugin that we actually hope to contribute back upstream to Ansible. So these are some of the things that, as we've written Zuulv3, we're hoping to make Ansible better and expose into Ansible that allows just Ansible as itself to become better. Oh, so I think that's all the time. Let's go back here. Like I said, if you do have more questions or more comments, feel free to come talk to me. Come to the #Zuul channel, ask. Zuul is really meant to be run more for non-OpenStack things. So for your testing environments and so on. Again, talk to myself, talk to Ricky. We have info people here. James Blair, if you want to get really technical on, for example, inheritance Y. Happy to answer all your questions. Hopefully you found it informative, and go get some beer. Thank you.